I wanted to give another or further explanation of the program that's in your lab book. Just as a recap here, the 74HC595 is a shift register, and what that does is it takes data from the input and displays it on the output, which is, in this case, is I have 8 LEDs that are connected to each of the output ports of the chip. All right, and if you might recall from the last video, we need to specify 3 ports. We need to have a data pin, which is where the data comes in, and then a clock pin, and the clock pin is what times the shifts. And then we have a latch pin, and the latch pin, the purpose of that is to hold the data on the output ports. Okay, now, the first thing I'd like to do is to just run this simulation so you can see what it does. Okay, now, 2 things here. First of all, you can see that it lights each LED in succession. When it gets past this one, we get a little red, I don't know exactly what that is. It's a warning, I suppose. And the reason why it's doing that is because at that point, with more than 6 LEDs on, when the 7th LED comes on, we're exceeding the current specification of the chip. I think that's somewhere around 80 milliamps, in that vicinity anyway. Okay, now, if you do this, build this actual circuit with the chip that's in your kit, you won't run into any problems. It doesn't get hot, it doesn't blow up or anything like that. But you are operating it outside the specifications. So if you were building something very critical, and you were going to have 8 LEDs on simultaneously for long periods of time, you might not want to use this chip because that's outside the specifications, and at some point it might fail. But for our purposes and for our experimenting, there's no problem at all. All right, let's go back to the code. All right, now, we've seen a lot of this before. Let's just jump down into the loop here. The first thing that we do is we have the variable LEDs, which holds the actual data. We initialize that to 0. We do the update shift register. We have a delay. Now what that does is it blanks out all the LEDs for a ½ second. Okay, now we've got enter into the for loop. Now, in the for loop, we have this command here that we haven't seen before, and it says bit set LEDs, I. Now, what that does is it sets meaning forcing a specific bit to 1. And here's the variable that it's doing it, and this is the bit position that it's forcing 1. So as you go through the for loop, it's starting out forcing the least significant bit to 1, keeping all the rest zeros. And then we have update shift register. Okay, so that gets displayed on the LEDs. 7 LEDs are off, but the most significant one, the one all the way to the right, is on. Okay, and we have a delay. Now we go through the loop and The second time, when I is now 1, we say bit set LED, comma 1. Okay, so now we have position 0, the bit all the way to the right, and then position 1, the bit immediately to the left of that. Both of those are now 1. We do update shift register, and so now when this gets displayed, we have those two LEDs on the right are now lit up, all the rest are out. Okay, we have a delay for a half second. Now we go through the loop, and now I is up to 2. So now we set the bit position 2. So now we have the 3 LEDs to the right that are lit up, and so on down the line until they're all lit up, and then it exits the for loop, it goes back up here, and then this blanks them all out for a half second, and then we go through the same thing. All right, just one other point here. There is a similar function in Arduino C that's called bit clear. And what bit clear does is it forces the bit of a variable in whatever position to be 0 instead of 1. So it works just like bit set, but the only difference is it's making the bit 0 instead of 1. All right, so let's just hide the code, and then let's just look at this simulation one more time, and you can have hopefully a better understanding now of what's going on.